Good afternoon to all of you. My name is Karthick, Department of Mathematics. Welcome you all. Seminar topic is application of mathematics in engineering. So, mathematics plays a crucial role in engineering. So, how it is, we will see. Mathematics is fundamental to all engineering disciplines, all engineering, medical, biomedical also. Engineers use math ideas to create, study, plan and improve systems and processes in many areas. From basic arithmetic to advanced calculus and differential equations, mathematics provides the tools necessary for problem solving, precision and innovation in engineering, problem solving, accuracy and new technology. So, here is a breakdown of how mathematics is applied in different engineering fields. So, first one I am taking civil engineering, structural analysis. Structural analysis means if we want to build a bridge, so first analysis the capacity of the bridge and strong and safety. So, this is called structural analysis. Engineers use calculus, linear algebra and differential equations to analyze stresses. Stresses means அந்த வெடிப்பு பாலம், அதுக்கு இங்கிலீஷில் ஹெவி லோடு, அப்போ டிஃப்ளெக்ஷன்ஸ் நோ 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 ராங் ஸ்ட்ரெஸ்ஸஸ் மீன்ஸ் மின்னல் இல்லையா, அந்த வெடிப்பு விழுகிறது. சரி, ஓகே. Strains and deflections in structures. Deflections means I think நேரான பாலம் நினைக்கிறேன். சரி, ஓகே. In structures like bridges and buildings under various loads and conditions. Example problem: a simply supported beam with a uniformly distributed load. ஒரு load வந்து அந்த beamல வைக்கிறோம். Determine the deflection of the beam at any point along its length. So that means அதனுடைய வளைவு, அந்த beam வந்து heavy weight இருக்கும்போது அது எவ்வளவு displacement ஆகுது. So deflection means வளைவு. ஈக்குவல் வெயிட்ஸ் இன் beam ஈக்குவலாக வெயிட் வைக்கிறது, அது மேலே வெயிட் வச்சு யூனிஃபார்ம் ஈக்குவல் வெயிட்ஸ். ஸோ we can determine the deflection of the beam at any point. அந்த பீமில் எந்த பாயிண்ட்லேயே டிஃப்ளெக்ஷன் ஆகிறதும் we can calculate as it's depending on the length. So engineers use differential equations, mainly differential equation. In civil engineering, transform and partial differential equation, unit 3 they studied to model the beam's deflection curve by integrating the equation, that partial differential equation, and applying boundary conditions also. Boundary condition means length 0 to L. They can find the deflection equation, and using that boundary condition we can find the equation and solve that equation. We can calculate the maximum deflection at the center of the beam. So mathematics, one of the application. So next one, mechanical engineering, kinematics and dynamics. Kinematics means the thing move one place to another place, that's all. Not necessary the things have particular weight or any special thing, it doesn't matter. The thing move one place to another place means velocity, acceleration, displacement. NF, these three NF, we can calculate the thing move one place to another one place. This is kinematics. Dynamics means forces given to that things. So, in mechanical engineering, what is the mathematics? Differential equations, calculus and vector analysis are used to analyze the motion of machines and mechanical systems. So, differential equation, calculus and vector analysis is the new one, because the direction. So, we need the direction of the things. So, that is why vector analysis also we used here in kinematics and dynamics. Next one, I will give example of this one, next slide. And thermodynamics also in mechanical engineering. Thermodynamics, energy, heat and work. So, using energy, heat and energy, and the output will become the work. This is called thermodynamics. Mathematical models are used to study heat transfer, for example, engine, energy conversion and fluid mechanics in engines and other systems. Example, determine the temperature distribution within the cylinder head of an engine considering heat transfer through conduction, convection and radiation. So, or example of this problem, we have to find the temperature distribution of the cylinder head. So, solve the partial differential equation. We know the partial differential equation, dou square z by dou x square equal to t dou square z by dou u square. So, solve that partial differential equation often numerically using computational methods, advanced computer, finite element analysis to find the temperature at various points with the cylinder head and predict how heat is transformed throughout the system using differential equation, partial differential equation used in this mechanical field also. And next, EEE, electrical and electronics engineering, circuit analysis and signal processing. Circuit analysis, suppose we have electric circuit, use mathematics, we have to calculate current, voltage, power, in AC, isn't it? No. Okay. We have using mathematics to calculate this analysis of circuit. Differential equations, complex numbers and linear algebra, mainly complex numbers used in AC, and linear algebra are used to analyze the design electrical circuits. Design the electrical circuits passing through the current, pressure, power, resistance. Resistance in one word, resistance also. I will give you the example of this circuit analysis after the slide. Signal processing, next one. Signal processing means through phone, we speak some words in the phone, that words convert into signal and to reach the opposite side. So, that processing using mathematics also. Fourier analysis, Laplace transform and other mathematical tools are used to analyze and to process signals in communication system, phone, audio processing, MP3, and image processing, photo also. Example of first one, differential equations model the dynamic behavior of circuits, particularly those involving capacitors and inductors in electric circuits. Using differential equation, thus we can find the dynamic behavior of circuits. Dynamic behavior means with respect to time. So, next one, how can Fourier analysis be used to separate noise from desired audio signal? இப்போ இந்த வீடியோ எடுக்கிறோம், இந்த வீடியோவில் நிறையா சவுண்டு வந்தாலும் அதில் நமக்கு தேவையான சவுண்டை வச்சுக்கிட்டு மீதி சவுண்டை ரிமூவ் பண்ணுறது தான் சிக்னல் ப்ராசஸிங். So how can Fourier analysis be used to separate noise from a desired audio signal? By applying Fourier transform to an audio signal, we can calculate the audio signal collected different types of audios. It can be converted from the time domain into the frequency domain using Fourier transform, revealing the different frequency components present in the signal. Noise typically occupies specific frequency ranges, hiss sound or low frequency something. Using this knowledge, one can design filters that attenuate or remove the noise containing frequency components, effectively clean up the original audio signal. Using filters we can convert the original audio signal. So next one also in EEE ECE, control systems. So mathematical modeling and control theory are used to design and implement control systems for electrical devices and systems. So this is the main word, electrical devices. We can control the electrical devices using mathematical modeling. Next one, electromagnetism. Electromagnetism means electricity, the relation between electricity and magnetism. They can control the power saving, current saving. So calculus, vector analysis and differential equation are used to study electromagnetic fields and their applications. So next, computer engineering, algorithm design. Algorithm means suppose a lot of numbers is there, we can find the largest number using algorithm, the concept of mathematics. So we can design the algorithm. Mathematical principles are used to analyze the complexity, difficult problems and efficiency, good one, correct answers. We can find the algorithm, using that algorithm exact answer. Next, data structures. So we can design the data using mathematical concept to design efficient data storage. நிறைய நம்ம ஸ்டோர் பண்ண முடியும் மேத்தமெட்டிக்கல் கான்செப்டை யூஸ் பண்ணி. அண்ட் retrieval systems, that means fast finding the folder. We can find the fast need data. நம்மளால் தேவையான டேட்டாவை சீக்கிரம் retrieval பண்ண முடியும். So example, what is the time complexity of a linear search algorithm? Suppose something big one, folders or lot of folders in your computer, you can find the single word yes, the relevant folders are there using mathematical concept. And example, another one, imagine a library with thousands of books. How can we design a system that efficiently retrieves books based on users search queries? We know the library, we can find to search the needed book. You can type the book first letter or second letter, that is arranged in the library systems using mathematics. So vector space model, each book is represented, query representation, similarity calculation, these are all in library using mathematics. Next, artificial intelligence, it is the machine learning. Artificial is machine learning. So thinking, machine க்கு நம்ம think பண்ண கொடுக்கலாம் mathematics using repeatedly upload the concept. நம்ம ஒரு கான்செப்டை ரிப்பீட்டடாக கொடுக்கும்போது அந்த மெஷின் லேர்ன் பண்ணிக்கும். So that is artificial intelligence. So optimization algorithms, linear algebra also here used, and calculus are used in machine learning and artificial intelligence applications. Next, IT, information technology, data representation and storage. Binary system means 0 1. So in IT, it's a machine language, they know. Binary system 0 and 1 is the machine language of IT to represent all data in these two words using to represent all data including numbers, text, images and sound. So, this system based on mathematical principles called on base 2 representation. Data structures and algorithm, here also mathematics used. Data structures, we can analyze the structure, design the structure. Mathematical concepts like sets, graphs and trees in computer science, discrete mathematics subject tells this sets, graphs and trees are used to organize and manage data efficiently. So, algorithms which are sequence of mathematical steps are used to perform operations on this data. So, next biomedical engineering, modeling physiological system, blood checking, blood checkup, another one muscle contraction and nerve impulse transition also using mathematical models in biomedical engineering also. So, analyzing medical data using mathematics we can analyzing. So, statistical methods, particularly statistical methods maths paper are essential for analyzing experimental data. உடம்பு சரியில்லை, நம்ம ஸ்கேன் எடுக்கிறோம், அதுக்கப்புறம் ஸ்கேனை வச்சு அனலைஸ் பண்ணி நம்ம கொடுத்த ட்ரீட்மெண்ட்டை எப்படியா இருக்குது அப்படின்னு அனலைஸ் பண்ணக்கூடிய அந்த மேத்தமெட்டிக்கல் மாடலிங் இந்த ஸ்டாட்டிஸ்டிக்ஸில் இருக்குது. அதுக்கப்புறம் அதுக்கு ட்ரீட்மெண்ட்டு கொடுக்க முடியும் நம்மளால். ஸோ இட் இஸ் எசென்சியல் ஃபார் அனலைசிங் எக்ஸ்பெரிமெண்டல் டேட்டா, இன்டர்பிரட்டிங் மெடிக்கல் இமேஜஸ் அண்டு கண்டக்டிங் கிளினிக்கல் ட்ரையல்ஸ் ஆல்சோ.